Welcome everyone. I will be talking about application security, but in a Golang and developer edition. I just refined my previous talks regarding application security. So, as if I said, I'm Mert. I'm security engineer at Amazon. I'm dealing with application security problems day to day within Amazon PXT, People Tech Security team. Briefly, I will be talking about some definitions first, and after that, I will briefly talk through the secure coding practices that you can apply when you're coding and implementing your day-to-day solutions. And after that, I will show you a brief automation part that you can apply to your day-to-day code or CI in order to automate some of the coding practices that we will be talking about. So in the definitions, I will first mention application security, after that threat modeling, SAST, and OWASP. So basically, application security for us is the measures that we're taking while we're developing or implementing our application. So basically, it drills down to the finding, fixing, and preventing security vulnerabilities all around the software development lifecycle. So it basically begins with requirement analysis and never ends. So while you're starting with requirement analysis in the lifecycle, if you don't know about the security or potential risks, threats that you're going to be having, you can always check some referential documents. And at that point, I would recommend OWASP. It's an open source initiative to raise awareness about application security overall, and they're having OWASP Top 10, and which nearly updated, and you can refer that document to learn about or having to know risks and potential threats for your applications. And the OWASP Top 10 lists the 10 most criticals for the web application security. So by knowing the risks and potential threats in the security scene for your application, you can actually, starting from the requirement gathering and use case through the development cycles, you can model your threats for your application. So it's basically a procedure that you're identifying your potential risks and threats for your use cases, and you're enumerating these threats and come up with a potential security controls so that you can make sure that you're prioritizing your risks accordingly so that you can implement them in your code. So having the threat model in your design makes your life much more easier, because when you're implementing or maintaining your application, you can always go back and see your threat modeling, and you can just check your potential threats and risks that you're addressed or not addressed, but documented over the threat modeling. So as I said, you will have your use cases and potential threats in the lifecycle, but when you're going to implement your use cases or the design into the code, you may or may not have addressed all of them, because you may not know all the risks or all of the potential secure implementations. So for that, we have static application security testing. It's shortened as SAST. So it basically examines your code to find vulnerabilities. It's much like similar to the Q&A testing, but for security purposes, you can think like that. So by performing SAST or static application testing in your code early and often, enables you to have at least minimal amount of vulnerabilities in your code while you're implementing your application. So at the automation part, I will mention how can you achieve it for your projects. So let's talk about secure coding practices and review common mistakes that developers are doing and their common mitigations that you can apply to your code. So first, I'd like to begin with input validation. So wherever you're getting a user input, there lies a potential security risk, because you cannot rely on users' ability to input something that is secure all the time, because there is lots of threat actors, bad users, or malicious ones that want to leverage your application on their behalf. So one of the common mitigations for validating the input is the whitelisting. Maybe you can whitelist the inputs that you're expecting from the user, escaping that you're getting the user input, but you're just escape some characters that may have potential security risks, such as these less than or bigger than characters that's commonly used for script tags, for example. So you can also check the boundaries and validations for the input. For example, if you're waiting for a string input, there's no reason for you to not checking that input is actually a string or numerical value or not, for example. And lastly, make sure that you're stripping all tags in your input, in the inputs that you're getting if you don't need them. There's a couple of libraries that already implement those validation and sanitization actions for Go, and you can use them for the input sanitization in your code. However, input validation alone isn't enough for the application to be secure in terms of the getting user input. You have to also encode your outputs, because since your inputs can cascade into the other apps or microservices and come back to you, it's important for you to have server-side input validation as well. That's what we are calling output encoding. So one of the examples in Go, for example, there is the parameter request. There's the HTTP request that gets the parameter, and by default, when you're saying test, it just gets content type as plain text. But if you're inputting tags, it turns into the HTML, which is not good for us, because you can just have these kind of parameter inputs from the user and run JavaScript into the application. So for this, allowing certain content types is not enough, although it's some kind of mitigation. What you can do, for example, is using HTML template, so that you can template the inputs and the parse accordingly. And when you're using HTML template, for example, in the code, it's going to sanitize and strip all the tags. And as you can see, the input type is still, content type is still the plain text. And the other common mistakes is the SQL queries. So there is a select statement over there which concatenates this customer ID over there. So the problem for that is when you run the query, since you're concatenating it, what happens if I just input 1 or 1 equals 1? So it's going to turn all of the rows from the credit cards, for example. So for this, we are using prepared statements to mitigate it. So you're building your query and make it as a statement. So it doesn't have to. It does not get malicious input like that within the string concatenation, for example. So authentication. So of course that all of our applications, one way or another, have authentication. So in its essence, it's a way for us to identify our users in a way. So for the authentication, it must be sent to an encrypted connection via post method. That the method would be post, because if you're using GET requests, these tokens or whatever you're using for authenticating a user we're going to be sent through URLs. So by sending it through URL, you're exposing your tokens or authentication method or authentication token within, there's the risk of exposure these tokens within the logs or within some kind of traffics. For example, when you're going into the common networks like Starbucks or at the airport, you can you may use common Wi-Fi's, and by sending these authentication fragments through GET methods may expose these into the common networks. And on top of that, don't forget to log your every successful or unsuccessful attempts with the date timestamp, because you're going to need it to detect if there is any problem with these authentication solutions. So ideally, you will have form with post method and autocomplete off. And also, you're going to ideally have CSRF value tokens. These tokens make sure that these forms are sent on its own, and you're going to identify these forms with these tokens so that you can prevent request forgery by using these forms. For example, if I were to embed this form to another page, and if a user who's authenticated to your website and browsing the internet may visit my website, and I can send this form on behalf of this user. So having a CSRF token would prevent these kind of incidents and for attackers to send requests on behalf of your users. And always make sure that when you're replying back to the user with an errors, you don't make your errors specific. For example, if your user gives your input wrong password, just say invalid username and or password, not invalid password, because that would enable attackers to enumerate passwords or potential usernames or mails or phone numbers, that whatever you're using to authenticate your users, to be enumerated by attackers just because you're giving the information that this user is on your database, but the password is wrong. So for the authentication, I would suggest checking out the hashing algorithms that OWASP is suggesting, because when you get the password from the user, you're going to hash them, but hashing them with a strong hashing algorithm is always good, because when you're in a case of your database or the passwords are compromised, they can be brute forced and cracked, and the passwords may expose. So that's why you're going to need strong hashing algorithms. So the examples of the common ones are the bcrypt, pdf-key2, argon2, and scrypt. Depending on your performance needs, you can use either of them. And never implement your own cryptography algorithm, and make sure that you're using whatever is accepted and generally used. Implementing your own crypto algorithm or implementing, for example, implementing bcrypt on your own is never a good idea, just because there is a vast amount of libraries or vast amount of frameworks that's already used commonly, tested by all of the community. So they less likely to have some kind of vulnerabilities or misimplementation that you may potentially do while you're implementing your own crypto. And just make sure that hashing a password is not in itself is not enough. So you need to salt your hashes. So the salting would be you're having the hash and you're just generating a random integers or values, so that you can concatenate these random values with the hash that you generated for your password, and that make your password password hash more long and hard to predict or crack. And I recommend re-authenticate your users just before performing critical actions, so that you can make sure that the users know what they're doing and the users is the actual ones. And implement multi-factor authentication whenever necessary for it. For example, when you're doing banking transactions or updating some information that's critical or sensitive to users, you can always ask for another way of authenticating the user other than the username password. That could be SMS, that could be some kind of token or Google Authenticator, these kind of two-factor authentication solutions. But make sure that implement those for sensitive actions for your users. And always monitor these kind of authentication attempts, whether it's successful or not, because they can be utilized the same password for multiple user accounts to try to compromise the users, compromise your users for your application. For example, there is a attack called credential stuffing. So it basically collects the username password combinations that's on the internet and that's already exposed. And by having these usernames, mails, and the passwords, these attackers can try these in your website. So if you're monitoring those authentications, you can identify whether you're being attacked by some kind of attacker using some kind of combo list of mails and passwords, so that you can remediate these attacks accordingly. So again, we talked about hashing and salting, etc. And as I said, neural crypto. Go already has crypto library. So for example, you can use bcrypt to hash the password and insert it into the database. And after that, you can use again compare hash and password function from bcrypt to check if user input user password is actually the one that you're having in your database. And once we authenticate the user, we're going to need to manage this session, of course. So for that, I recommend generating a session identifier that's strong enough to not forged or brute force identified by using brute force solutions. So for this, you can just generate JWT token, JWT signed token, signed with a secret, so that it cannot be forged for someone else. Having your cookie HTTP only secure flags in the cookie enables you to send these if you're having this token in the cookie, enables you to send your cookies securely for your sessions. And again, never use your old sessions. Just make sure that your users have a new session every time they're visiting your website or application, and never expose these identifiers in URLs. So that it comes back to the first authentication form that we discussed. If you're sending these through GET requests and in URLs, it's going to be exposed one way or another, whether it's on the network or in the logs. Somewhere it's going to be exposed, and you never want these tokens or keys to be exposed, because when it's stolen, it can be used by someone else. So we authenticated the user, we manage the session, so there comes the access control then. For this, we talked about JWT token, but it can be other kinds of parameters or methods that you can use to manage access for the user, but make sure that it's a single one, so that you can have one solution for your access authorization, and you're using it for all your sub-domains or sub-components of your applications, and enforce them in every request that's necessary for a user action. And these access controls should fail securely. For example, if I were to visit my profile, if there's any problem for it regarding access control or another way, I should not be able to visit my profile and see my information. So it should fail securely. You can use a defer feature to achieve this, and always make sure that you don't leak information while failing. So also the other thing that you need to make sure is that your front end or your application backend or server side should have the same access control rules all over the place. So not only you need to have a single access authorization mechanism used site-wide, you also need to apply this site-wide mechanism also in your backend as well, so that you have one integral access authorization rule or controls. So in any case that you're not using JWT, for example, when we're having JWT, we have signed token, signed with using secret, for example, in the other example. So if you were to use other mechanism other than the JWT, and if you need to store this on client side, for example, make sure that you're using encryption for this, and always perform integrity check for it, because it can be tampered. For example, if you're using some kind of value in the cookie and you're storing it into the browser's session or some other place on the client side, if you don't encrypt it, user can tinker with it. And if you don't check the integrity, user can just change the value or change itself to the another user to impersonate, for example, and you may put your users at risk just because you didn't enforce encryption and integrity check to these control tokens. So again, never implement your own crypto. Always use whatever is already in public and widely used, so that you can avoid making mistakes for crypto. Also monitor your vulnerabilities. Monitor vulnerabilities in the packages or modules that you're using, so that you can always make sure that your modules are 100% updated and vulnerability free. For example, just last week, there was a critical vulnerability that Log4j has. For example, look for these kind of vulnerabilities by using, for example, dependency track kind of open source tools, so that you can make sure that your modules are safe. And if you're using containers, please make sure that you minimize your containers. By minimizing, I mean that your containers only have modules or the environment that your code needs in order to run, not the other fragments, packages, or functionality whatsoever. So you can achieve this, for example, by using Minicon. And after that, make sure that you're scanning your containers using, for example, Tree, to make sure that your containers is updated and secure against the vulnerabilities that's known for containers. So we talked about lots of things. For example, we talked about input validation, output encoding, SQL injection, authentication related vulnerabilities, which can born from cryptographic issues. So how do we integrate automation to our pipeline or to our day-to-day coding activities, so that we can make sure that at least the nullments can be ruled out with automation while we're developing the application? So the process I will introduce is the commit-based scan. You're going to write your code and commit. While committing, you're going to scan. So you're going to perform static scan. So for this, you can employ pre-commit scripts and SamGrep scanner. SamGrep is the open source static application scanner that has community-driven rules that you can use for your applications depending on your language. So for example, if you visit samgrep.dev/r, there's a bunch of rule sets that community is developing, and they are updated pretty regularly. So there's also rule sets that covers Go, and by setting up pre-commit hooks and configs, and these sample hooks and configs you can find on SendGraph's GitHub. You're by setting up these pre-commit configurations, whenever you're committing, SendGraph can run the rule set that's needed for your application, and list potential vulnerabilities or the risks that you have in your code. So by setting these mechanism in the CI pipeline to run pre-commit hooks whenever a pull request is made, and by disabling the direct writing to the main branch, you can make sure that every commit is scanned by SendGraph, or you can say every commit is scanned by static scanner according to the rule that you're implementing your code, so that you can make sure at least the rule set covers the vulnerabilities that's widely exploited or widely widely mistaken by the developers. So thank you for listening to me.